Hi everyone, welcome to this new lecture of fluid mechanics. In this lecture, we'll discuss a problem related to stream and velocity potential function. In our previous lectures, we have already discussed the theory part of this stream and velocity potential function. So let's solve a problem related to this concept. So here I have taken a question. If for a two-dimensional potential flow, the velocity potential is given by phi equal to x into 2 minus 2y minus 1. So let me write this equation x into 2y minus 1. Determine the velocity at the point P equal to 4 and 5. Determine also the value of stream function at the point P. So the question is simple. First we need to find out the velocity potential function, then we need to find out the stream function. So first we'll start the velocity potential function. So we know that the velocity component in the x and y direction that we have seen u equal to minus del phi by del x, and v equal to, we know that minus derivative del phi by del y, u in the direction of x, v in the direction of y, and just you put this value minus of del with respect to del x, square bracket start, and x into 2y minus 1 bracket close. Just to derivative of these things, what we'll get, minus term will be there, del x by del x 1. So derivative of this 2y minus 1 constant term, we can take it out. So what will be there, minus term, you take it inside. So 1 plus 2y will get, okay, sorry, 1, this is minus will be there, 1 minus 2y, okay. Similarly, derivative of this term with respect to, again, y. So similarly, what will get, 2y minus 1. So here we will get the value of minus 2x, okay. So next what I can write, this is the velocity component what I got. Now at this value, at this equation, this one and this one, we just put the value of p, 4 and 5, p, 4 and 5, that means x and y value, just put this in equation. So what will get, u equal to, we know that 1 minus 2y, so 1 minus 2 into y value how much, now 5, so we can get 10, 1 minus 10, that is minus 9, that will be the units per second. And similarly, v, we can write what the value of here, minus 2x, so 2 into x value how much, 4, so that is minus 8 we can write. So this minus 8 is nothing but the units per second. So if you write the velocity at the particular point, or you can say the velocity at point P, we can write the velocity at P, we can write this u value how much, now minus 9, write in this vector form, ik minus 8j, okay. And if you want to find out the resultant force or resultant velocity at P, so that also you can write the resultant velocity at P equal to, we can write, we know that just x square and y square, that root we can do, so 9 square plus 8 square root over, and we'll get 81, and this is 64, so near about 140 something will come, so that will be there 12, so 12 point some value will become there. So this is unit per second. So this is the first one. Which one? The velocity potential function. Similarly, we can find out the stream function. So stream function also, again, we know the formula for this. At this particular point of P, we need to find out the stream function. So for that, stream function symbol is also different. So we know that the stream function, we got there del psi by del y, that is right angle, this is straight in the same direction, this is right angle direction, okay. So minus u, okay. And here what we can write, this value of minus u, we can write 1 minus 2y, so here we'll get 2y minus 1, okay. And similarly, we can write for the del psi by del x, that is equal to v. This is reverse case, okay, because it is, as per the definition, we know that this is the velocity we need to consider in the right angle to the direction. So if you see the video previous theory, you can understand that one. So v equal to minus 2x, we can write here. So this is one equation and this is one equation. Now what we'll do, suppose this is equation, some equation you can give here, equation 1, and this is you can give equation 2. Now what I'll do, just I'll integrate the first equation. So first equation what I got, now del psi by del y equal to 2y minus 1. And what I'll do, I'll write del psi, I can write in this way, 2y minus 1 bracket it, and we can write here del y. And now I want to integrate this equation. Okay, if you integrate this equation, what I'll get here, now psi equal to integration of 2y dy, that will be 2y square by 2, and this is integration of dy, that is y. And though this integration part is there, we can keep a value of, constant term. So the constant term you can keep c or k or something, some constant value you can keep it here, that is constant of integration. Okay, so this constant of integration will be not a function of y, that we know. Okay, but it can be a function of x. Okay, so what I can write, let find out this value of constant of integration. So you can write the psi equal to y square minus y plus c, suppose. Okay, so this is equation 3, let me give it here. Now next what I can write, now differentiate this equation, let differentiate this equation del psi with respect to del x, because we cannot differentiate with respect to y. So let differentiate with respect to x, then what will get, now difference of this will be not possible, y square and y. So this constant term what will do, so let c differentiate of this with respect to x. Okay, so this term will be cancelled. So now what we've got here, now del psi by del x equal to del c by del x. So in the previous equation, if you see, we have, what is there, another one equation is there, let me show you this one, del x by this value, del psi by del x equal to minus 2x. So now just write this value from this equation, we can write del psi by del x equal to minus 2x. Now if you equating this 2 value, so what we can write here, now del c by del x equal to minus 2x, that we can write. Now again I can put this value here, what I'll write, del c equal to integration, I want to integrate these things, I want to get the value of this constant one. So what I'll do, minus 2x into del x. Okay, so next what will do, if you integrate this one constant term, we'll get here, suppose c, integration of this del c, you will get c, and here minus term will come out 2 into, we know that x square by 2. So finally what we'll get, then minus x square. So the constant term what we got here, minus x square. Now this again we'll put this value of c in the previous equation, then what we'll get here, now we can get the value of psi equal to, what was there, now x, y square minus y, and plus c value is minus x square, so you can write minus x square. So this is the value of this is the equation. Now we need to find out the p point, we need to find out the stream function at p point. P point equal to how much is given at this 4 and 5 point. So what we'll do, we'll just put the value of p at in this I, that is p equal to 4 and 5. So just put the value, what we'll get here, psi equal to 5 square minus 5 minus x square, that is 4 square. So what we'll get here, 25 minus 5 and minus 16. So if you see, find 25 minus 5, 16, 20 minus 16. So that finally it will be 4. This is 4 units per second, that will be there. Okay, so this is the value of psi at this p equal to 4 and 5. Now similarly we got the value of this velocity of p, or point of value of p in the 4 and 5 for the velocity potential function. Similarly the second term, stream function, that also we can write the p at the point of 4 and 5, we can write this is unit per second. So I hope you understand how to solve the problem related to stream function and velocity potential function. It is very easy actually. Only we need to remember these are the points, these are the formula we need to remember. This is the formula as per the definition of velocity potential function. The velocity components in the particular direction we need to consider with negative value. Okay, but here For the stream function, you need to consider the right angle value. We need to consider the right angle velocity component in that particular. Suppose the velocity, the fluid is moving in x direction, then we need to consider the velocity of in a y direction velocity. Okay, see, del psi by del x, we have consider v value. If you consider this is v positive one, then other flow we need to consider negative. That's why I have taken here del psi by del y velocity minus uv here. That is the two things only. We need to keep the formula remember in your mind so that we can solve the problem. I hope you understand. If you are having any kind of query and doubt regarding this, you can give a comment on the comment box. Thank you.